In this video, I will show you how to graph cube root functions such as this one. Now, first of all, understand the basic concept of a cube root. If I take numbers like 1, 2, and 3, and I cube them, 1 to the third power is 1, 2 to the third power is 8, that's 2 times 2 times 2 is 8, 3 to the third power is 27. So if I then say, what is the cube root of 1? What is the cube root of 8? What is the cube root of 27? The cube root of 1 is 1, the cube root of 8 is 2, and the cube root of 27 is 3. So basically these numbers right here are the cube root of these numbers over here. We're kind of uncubing these numbers. Alright, so understanding that that's what cube root means. Alright, those numbers that I just showed you, the 1, 8, and 27, those are convenient numbers that we can take the cube root of. But understand this. Sure, the cube root of 8 is 2. But what about the cube root of negative 8? Well, that's just going to be negative 2. We can't take the square root of a negative number. That's imaginary. But you can take the cube root of a negative number because it works out just fine. Negative 2 times negative 2 times negative 2 does give you negative 8. You don't need imaginary numbers. Alright, so with that in mind, we are going to use the same 5 values over and over again. Alright, these are the sort of small numbers that we can easily take the cube root of. So let's see, so my x's and my y's, 1, 2, 3, 4, 5. So we will use negative 8, negative 1, 0, 1, and 8. Alright, these are the 5 small numbers that I can easily take the cube root of. And the cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So these are the 5 points that we will use to start off with for all cube root graphs. Now for this particular graph, that's it. We're just graphing this parent function. So we'll just graph these 5 points and sort of take a look and see what we have. So negative 8 comma negative 2 is going to be off the graph a little bit, so approximately here. Negative 1 comma negative 1, 0, 0, 1, 1, and 8, 2 would be about here. And we could keep going to the left and to the right. So unlike the square root graph, which sort of starts at a single point and goes in one direction, cube root graphs go in both directions forever. So this graph is going to look like this. Kind of going to the right, it looks a lot like a square root function. But it also goes to the left like this. Now, because of that, the domain and range are always going to be negative infinity to positive infinity. Alright, all cube root graphs have a domain and range of negative infinity to positive infinity. No exceptions. There is no starting point for a cube root graph. So from left to right, this graph is increasing. See how it's rising? So this is definitely increasing. End behavior. Okay, and as usual, this means as we go to the left, what happens to the y values, and this means as we go to the right, what happens to the y values. So as we go to the left, the graph is falling, falling, falling. So as we go to the left forever, the graph is falling. So we will have negative infinity, negative infinity. As we go to the right, this graph goes to the right forever, so that's positive infinity, and it is increasing. So as we go to the right, this graph is rising, that's another positive infinity. that's going to do it for the parent function here, cube root of x. Now let's take a look at number 4. The only thing that's changing is this little negative sign right here. Now I'm going to encourage you to look at that as an a value of -1. So look at this as -1 times the cube root of x. Now when we learned about square root functions, we talked about all these transformations, all right? Your a value, your b value, your h, and your k. Now guess what? These will be all the same for a cube root function. I'll just like stick a little 3 in there. I'm cheating. The transformations are the same. Vertical stretches, compressions, reflections, all of that. So when you have a negative sign out in the front, that is going to be a reflection over the x-axis. So we should expect this graph to be the same as number 3, but sort of upside down, reflected over the x-axis. But the procedure of the way you go about just graphing it, as far as the steps, as I mentioned before, we always start off with the same 5 values. So that makes it really easy. Just start with your chart of 5. Alright, and your 5 values will always be -8, -1, 0, 1, and 8. Every single time you do a cube root function, start with these values. And we will start with always the same y values, the parent function, -2, -1, 0, 1, and 2. Just the cube root of all of these. Now, if you have an a value, you make a new y column. If you have a b value up underneath the radical, then you make a new x column. So since we have a new a value, then I am going to make a new y column. So alright, so we're just going to extend this out a little bit. So your y column is just the a value times the y. So I'm going to do -1 times all of the y values. So if I multiply all these by -1, all that does is change the sign. So I'll have 2, 1, 0, -1, -2. I have a new y column, so I can throw these out. And you can see how all this is going to do is turn everything upside down. So I can go ahead and plot these points now. I'm going to have -8, comma 2. So -8 would be about here, comma 2. -1, comma 1. 0, comma 0. 1, comma -1. And then 8, comma -2. Alright, so this graph is going to look like this. Okay, it's a little scraggly there, but you get the idea. And it is the same as this graph, just upside down, which is what we predicted. Now, there was no starting point. This graph is decreasing. From left to right, it is going down. So this is decreasing. The domain and range for all cube root functions will be -infinity to +infinity. Which makes sense because domain, it goes left and right forever unbroken, and it goes down forever and up forever. So that's why the domain and range is -infinity to +infinity. And behavior, it goes left forever, but as we go to the left, it's rising, so +infinity. Now, on the right-hand side, it goes to the right forever, so +infinity. But as we go to the right, it is falling, so I'm going to put -infinity. Alright, that's going to do it for problem number 4. As we take a look at number 7, when you have a negative sign here, that's going to be a reflection over the x-axis, so watch out for that. This a value, ignoring the negative sign, we have this 2. That's going to be a vertical stretch by a factor of 2. And then the -3, that's going to send, this -1 is going to take us to the right 1, and the +3 will take us up by 3. So as far as graphing this thing, we always start off the same way. Alright, we are just going to make our same 5 values. So x, y, and 1, 2, 3, 4, 5. Okay, so we will start as usual with -8, -1, 0, 1, and 8. And the y values will be the cube root of these, so -2, -1, 0, 1, and 2. Now, when you have an a value other than 1, what you do is you make a new y column. So that's what I'm going to do right now, is I'm going to make a brand new y column. And you just simply do a times y. So I'm going to do -2 times all these y values. So that's going to give me +4, +2, 0, -2, and -4. If there's ever a b value, then I make a new x column. And I actually have to do the reciprocal of the b value. But this doesn't have a b value other than 1, so I don't need to change the x column. But now that I have a new y column, I will throw out my old y column. And I'm going to go ahead and graph these points. Now, I'm not going to do anything with the -1 and the 3. After I graph these points as the parent function, I will move them all right 1 and up 3 because of these transformations. But for now, I graph. So -8, 4, that's going to be here. -1, 2 would be here. 0, 0, 1, -2, and 8, -4 would be here. So I'm going to treat this as the parent function, and now I'm going to shift everything right 1 and up 3. So right 1 and up 3 would put me here, right 1 up 3, right 1 up 3, right 1 up 3, right 1 up 3. Okay, so this graph is going to look like this. Okay, so there you go. And there's no starting point. This graph is decreasing from left to right. It is falling. So that's decreasing. The domain and range, of course, will be -infinity to +infinity. Left and right forever, and it goes down and up forever. It goes to the left forever, so that's -infinity. And as we go left, it goes up. The graph does go right forever, so as x approaches +infinity. And as we go to the right, the graph is falling. So the y values approach -infinity. All right, that's the end of our analysis for problem number 7. All right, one more. Problem number 8. This one has a b value. Now, a negative sign here on the b value is a reflection over the y-axis. So keep that in mind. The b value controls horizontal stretches and compressions as well, looking at the 3. But think reciprocal, think 1/3. So this will actually be a horizontal compression by 1/3. And then left 2, down 4. This is always the opposite of the way it looks, left or right, but positive sends you to the left. So keep all that in mind as we do this. Now I'm just going to recopy this so I don't have to scroll. So I have y equals, alright, the cube root of -3 times x plus 2 and then minus 4. Okay, so as always, one more time, when we are doing a cube root function, we will start off with the same 5 values over and over and over. So we have our x's and we have our y's. 1, 2, 3, 4, 5. Our usual x values are -8, -1, 0, 1, and 8. And of course the cube root of these give you the y value, so this will be -2, -1, 0, 1, and 2. Now, as we have seen on previous problems, when you have a b value, you're going to make a new x column. So I will just extend these lines for my new x column. But you don't simply multiply b times these x values. You do the reciprocal of b. So I'm actually going to multiply all these x values by -1/3. So the reciprocal of b. So I'm going to do -1/3 times all of the x values. So all the signs will change, but also I am dividing by 3. So I'm going to have some decimals here. So if I do 8 divided by 3, just using a 4-function calculator, that would give me 2.7. So this is going to be a positive 2.7, because a negative times a negative is a positive. So multiplying by 1/3 is the same thing as dividing by 3. So of course 1 divided by 3 is just 1/3. So that's going to be approximately 0.3. 0 divided by anything is still 0. Now, if I do 1/3 times 1, that's still going to be 1/3. But this time I'll have a -1/3. And dividing 8 by 3, again, we saw that that was 2.7, but this time it'll be -2.7, because negative times a positive is a negative. So we have our new x column, so I will disregard my old x column. So I'm going to go ahead and graph these points, but this will be the parent function, because we still have to go left 2 and down 4 later. So 2.7 comma -2. Alright, 2.7 comma -2, that's going to be about here. And then 0.3 comma -1 will be about here. 0 comma 0. Now -1/3, or I guess to be consistent I could say -0.3, like I did for all the rest. So -0.3 comma 1 would be about here, and then -2.7 comma 2 would be about here. Okay, now this is the parent function, so I still need to do these horizontal transformations. So I need to go left 2 and down 4. So these 5 points represent the final graph. So it's going to look like this and like this. Alright, now Now again, there's no starting point for a cube root function. From left to right, you can see this graph is falling, so it is decreasing. The domain and range, as usual for a cube root function, will be negative infinity to positive infinity. It goes left and right forever, and it goes down and up forever. And end behavior. This graph goes to the right forever, so that's positive infinity. As it goes to the right, it is falling, so negative infinity. This graph goes to the left forever, so that's negative infinity. And as it goes to the left, the y values are increasing, so that is positive infinity. Alright, that is going to do it for this problem and this video. I hope it was helpful, and I will see you on the next video.